All right. Thanks everyone for taking the time today. Very excited to see you all here. My name is Irina. I'm a product manager in our Vertex team responsible for evaluation and explainability. We're going to talk about the evaluation piece today. And my colleague Ivan is joining me.
Hi everyone, I'm Ivan Nardini. I'm a customer engineer on Google Cloud, working on AI ML topics. I'm happy to be here to assist Irina in this presentation.
Beautiful. All right, so quick agenda for the day. We're going to talk about how to evaluate generative models because that's a question that lots of our customers have today. There is a lack of confidence in how these models perform, and this is what's keeping so many applications from going to production. So we hope to demystify that and explain a bit our approach for how to handle evaluations. Ivan is then going to show a demo of our latest evaluation tooling, which is called Auto Side by Side, and then we're going to finish it off with a round of Q&A. All right, so let's dive in. Evaluating Gen AI. On the surface, evaluating Gen AI actually looks like evaluating predictive models, right? You specify your goals, you choose your eval methods, you compile your data sets, and then you get results that you then analyze and interpret and go next. It's actually not that easy with Gen AI, and we see a number of challenges, both in our internal teams as well as customer teams. First of all, evaluating generative tasks is very difficult as it's next to impossible to capture the essence of a good generative task in just one metric. Think about a newspaper article or a painting. It's not even a technical limitation. It's the nature of these things that there's a subjective element to it and that it's not different to capture performance in one dimension. And also, lots of you in this call will have a very different take of how a good painting or a news article should look like. Still, we can define a number of proxies and criteria, right? When we eyeball results that a large model gives to us, we have a set of criteria in our head that we're looking for. And well, it's these criteria that we can try to capture in say, a formula. Then there is a lack of understanding which evaluation methods exist. This field is very new methods come up. There's a lack of certainty in what is tried and tested and already used in production versus what is only very, very novel research. And we hope to alleviate some of that today. There is difficulty in the question of what a good data set looks like. First, we start with the question of, okay, there's a lack of data sets, I might not have them. But if you dive into that problem, it's actually more of I don't understand how large my data set needs to be. In the predictive model world, we dealt with very large data sets. Do I need the same size? How does a good data set look like? And then at the end, once I get a metric back from the evaluation method that I've chosen, what do I do next? How can I interpret this result? Is this a trustworthy metric? How can I put this in context? So lots of questions, and we're not going to solve everything because this is still a very new field that's rapidly evolving. But there is a couple of pieces that we'd love to bring to the discussion today. Because one takeaway from looking at all the slides with challenges might be, all right, it seems that this is next to impossible to automate. Let's just do it myself. And I want to illustrate that with this example. So here is a chatbot. You ask it a couple questions. Actually, you ask it one question and then a follow-up. And you have two assistants replying to you. And you have two goals here. One is to understand if either of the assistants is doing a good job, and then to understand which one you actually prefer. I'll pause for a couple seconds to let you look into that and just read it yourselves. And because I'm not patient enough, I'm going to skip to the next slide before you all start finished reading, but you still have this interesting clip here on the left. This piece for me, and Ivan tested it as well, it took us about a minute to review it. It's just awkward to pause for 1 minute, or I don't have the patience for that. This is why I can't leave it on for 1 minute, but think about that. This case for manual review, takes about 1 minute. And what we commonly see is people have hundreds of QA pairs. So it's quite a time commitment. And what we're trying to say here is human evaluation is very important. And in Gen AI tasks, this is still the gold standard. At the same time, we need to find approaches to automate evaluation, because otherwise it's very difficult to get to production confidently because we can only evaluate on quite a small portions. So what we want to talk today is about methods to automate evaluation so that we can scale the number of evaluations that we're doing. And there's a couple tools that we have at Vertex today to actually conduct these evaluations. One is Autometrics. This is very, very similar to how we did evaluation in the predictive model world. Ultimately, here you have a metric that compares the new model output to a ground truth. So this requires you to provide a labeled data set. It actually is not as large as some of you might expect. A couple data points might suffice to get a good indication of if you're going in the right direction or not. And then basically what we're doing is computing a metric. And you see here Rouge L sum and Bleu metrics you've probably heard of. So Rouge, for example, is a family of metrics that's quite useful for evaluating summarization tasks. So this is the fast and efficient method that you see across the board, that you also see mentioned in a lot of technical reports. It's important to keep in mind that these metrics have a limit in alignment with human preference. So what do I mean by that? Autometrics are very useful to understand if I'm going in the right direction and to guide model development. At the same time, we cannot use an autometric as a North Star, at least not today, because something like Rouge measures ultimately the similarity between the ground truth that you provided and the new output. This is one dimension that you want a summary to have, but there's other dimensions that are important for you as well in the summary. And this is something that the metric doesn't capture. So autometrics, very useful to guide development, not useful as a North Star. Another tool is auto side-by-side, and I'm gonna skip that because this is what we're gonna dive into today. And the third piece is safety bias. So autometrics and auto side-by-side are very focused on evaluating the quality of your output. And safety bias takes a bit of a different lens and tries to understand if there is bias in my model responses. And it explicitly looks at, is there bias in my safety filters towards a certain identity group? So one example that it could detect is that my model is producing more toxic content when for females compared to males. All right, but today we want to dive into auto side-by-side. So what is auto side-by-side? Ultimately, the task we've just seen, this chatbot that gives you a response, and there's assistant A and B with two different models that you're trying to compare against each other. This exact workflow is what we're trying to automate with auto side-by-side. Think of that as A/B testing your LLM. You have two models. You provide a pair of input prompts. You provide a set of input prompts. Then these prompts are given to two models and they produce an output. Now, the input prompts and the outputs are bundled together and sent to a third model. And this third model is a judge model that is ultimately going through the responses row by row and rating which one is doing better. And what you get in the end is an aggregate win rate that tells you that, say, model A is winning. But it's important for us that you don't only look at this win rate, but actually go into all the details that we provide and scrutinize the results. So this is first the row-based view. So as I said, there's the input prompt and both model responses, and then the judge's decision. So you can look at that and see if it aligns with your preference or if something is going wrong. The judge also gives an explanation for why it favored one model over the other. So that's another piece for you to look into and see if the rationale that the judge applies is something that aligns with your preferences or not. And the third piece of that is a certainty score. That's a score between 0 and 1 that tells you how certain the judge is in its decisions. So auto side-by-side, in a nutshell, a tool to A/B test your LLMs. We're using a judge model under the hood. And next to the aggregate metric, which is the first piece that you see, hey, model A is the winner, there's lots of details that help you put these judgments in context and see if they align with your preference. So let me go forward. So today, the service works for summarization and question answer tasks. We're working on expanding that, but how you can see the product today is that we have specific raters that evaluate performance on a specific task based on a number of criteria that you can see in our documentation and that I will bring up in the slides. So at this moment, auto side-by-side will work for summary and QA, and we're expanding that to also capture more tasks. One other thing that I want to mention here as well, because I saw it in a number of questions that came before, with auto side-by-side, you can evaluate any model. In fact, you can evaluate any output. So you can either tell us, okay, there's model A and B, and I want to compare them against each other. And as seen on the previous slide, we run the inference and send the results to the autorator. What you can also do is you can ingest your own inference result, and that can be from any model or from human raters. And then auto side-by-side uses that as a comparison. Okay, so how this evaluation actually works is that it's built a lot on the criteria. And here in this next slide, you see a very high-level view of how these criteria look like for a summarization task. So for summarization, we focus on these 4 criteria. Does it follow instructions? Is it grounded? Is it comprehensive? Is it brief? Now, we understand that you might have different criteria, and this is why, as a next step, we will have an autorator that is customizable. So that allows you to specify the criteria you care about. What we see today is the pre-built autorator. All right, and with that, I hand it over to Ivan to show you how to get started with auto side-by-side.
Thank you, Rina. So hi, everyone, and thank you again for joining us. In this second part of the session, we are going to talk about how you can get started with auto side-by-side. So let's assume that you want to evaluate a large language model available on Vertex AI, like Gemini Pro, on a specific task against another one using auto side-by-side. And let's say that you already have your LLM generated predictions. These are the steps that you need to cover in order to evaluate them. First of all, you need to prepare the evaluation dataset, which means that you need to collect your prompts, context, and the generated responses required for running the evaluation. Then you need to convert the evaluation dataset either in a JSON-L format and store it in a cloud storage bucket, or save the dataset to a BigQuery table. And finally, you can use Vertex AI to run a model evaluation pipeline job. Now that you know these steps and you're familiar with them, let's dive into them. So let's assume that you're going to compare 2 LLMs in a summarization task. With a flexible schema, auto side-by-side accepts a single evaluation dataset. In this summarization use case, we have a JSON-L format. And as you can see, each row in the evaluation dataset is a single example, and it contains several fields. In particular, if you look at the schema, you have some ID fields that are used to identify each unique example. And in this case, you have the ID field and the document field, which contain newspaper articles to summarize. Then you might have some data fields, which can be prompt and context, and they will be used to fill out auto side-by-side prompt templates. In this case, we don't have it. But what we have is the pre-generated prediction, which contains the generated responses according to the LLM task. And here you have the response A and the response B, which represent different article summaries generated by different models. And finally, you may have human preferences, which are used to compare auto side-by-side auto-rated preferences against your human validated preference data. In terms of evaluation dataset best practices, as always, we recommend to use simple examples that represent the real-world scenario where your LLM-based application is running, and include a minimum set of evaluation examples in your dataset. In particular, in this case, to ensure high-quality aggregated metrics, we suggest using at least 400 examples. Now that you have an idea of how the evaluation dataset might look like, and we assume you upload it on a Google Cloud bucket, we can focus on defining the model evaluation pipeline parameters. Auto side-by-side release on Vertex AI pipeline to run a model evaluation job. And here you can see the main supported pipeline parameters. In order, you have first the evaluation dataset parameter to indicate where the evaluation dataset is stored. In this case, is the JSON-L cloud bucket we created before. The ED fields to distinguish evaluation examples that are unique. And here, as you can imagine, we have ED and document, and also the evaluation task to indicate the task type we want to evaluate. It can be summarization or question answer, and in this case, we have summarization. Additionally, auto side-by-side support configuring the auto-rated behavior, and you can specify inference instructions to guide task completion, as well as setting inference context to refer during the task execution. Lastly, user have to provide the names of columns containing predefined predictions in order to calculate the evaluation metrics. Once you define those parameters, now you are ready to run the evaluation job. As I said, auto side-by-side leverages Vertex AI pipelines, and Google Cloud provides a pipeline template that includes all the essential steps to evaluate your LLMs with respect to the predefined task. Submitting an auto side-by-side model evaluation pipeline job on Vertex AI is straightforward. First, you initiate a pipeline job by passing the defined parameters and the pipeline template. Then you submit a pipeline run using the Vertex AI Python SDK as shown in example here. After the evaluation pipeline successfully run, you can review the evaluation results in the Vertex AI pipeline by looking at the artifacts generated by the pipeline itself. Auto side-by-side produce three main types of evaluation results: a judgments table, aggregated metrics, and aligned metrics. This if human preferences are provided. The judgments tables contains metrics that offer insights of LLM performance per each example. So for each response pair, the judgment tables include a choice column, which indicates the better response based on the evaluation criteria used by the auto-rated, and each choice has a confidence score between 0 and 1, representing the auto-rated level of confidence in the evaluation. Last but not less important, auto side-by-side provides an explanation for why the auto-rated preferred one response over the other. This capability is so powerful because it allows you to assert that one response is preferable to another one due to a specific and explainable reason with a certain confidence. Here, you can see an example of auto side-by-side judgments output. You can see that the summary from the model B was preferred of the summary of the model A due to its higher coverage, coherence, and better form. Auto side-by-side provides also aggregated metrics as an additional evaluation results. These win rate metrics are calculated by utilizing the judgments table to determine the percentage of times the auto-rated prefer one model response. These metrics are relevant for quickly find out which is the best model in the context of the evaluated task. At this point, you may wonder, how about validating these auto side-by-side judgments with respect to human preferences? The good news is auto side-by-side support human preferences. And in this case, you need to provide some additional information and parameters in the auto side-by-side pipeline. With respect of the evaluation dataset, you need to add a column which contains the human preference with respect of the LLMs generated responses. And here you can see an example with the actual column that expresses these human preferences. Also, in terms of parameters, you must specify the human preference column in the auto side-by-side pipeline before to running it. And the rest of the process remains the same. You can run the evaluation pipeline job using the Vertex AI Python SDK, as you can see here. And compared to what I showed you before, now the pipeline returns additional measurements that utilize human preference data provided by you. And here, you can see the result output that you may obtain. In addition to well-known metrics like accuracy, precision, and recall, you will receive both the human preference and auto-rated preference scores. These scores indicate the level of agreement between the evaluations. And to simplify this comparison, Cohen kappa is provided. Cohen kappa measures the level of agreement between auto-rated and human rates. It ranges from 0 to 1, where 0 represents agreement equivalent to a random choice, and 1 indicates perfect agreement. In this case, it appears that auto-rated and human preferences diverge. It may happen, and this discrepancy will require further investigation. All right, now that you are familiar with both the process and the resulting auto side-by-side metrics, let's see auto side-by-side on Vertex AI in action. In this demo, we are going to compare two LLMs in a summarization task, and one of these LLM is Gemini Pro, which is available on Vertex AI. The dataset we are going to use is a modified samples of the XSUM dataset, which is a common dataset to evaluate summarization systems. So with that being said, let's jump into the demo. So if you don't know how Vertex AI looks like, so this is on the left, you have a series of services that covers the entire model lifecycle, and we are going to use Colab as a notebook environment. As I anticipated, to evaluate Gemini Pro, we need the evaluation dataset, which in this case is made by an ID column, the document column represented by newspaper article we want to summarize, and two different summaries options generated by two different models. Once we have the dataset and we upload on the cloud bucket, we need to define model evaluation pipeline parameters. So we indicate where the evaluation file is. We indicate the response column, both for model A and model B. And then we pass those parameters to a pipeline job, which what it does, it generates a pipeline runs on Vertex AI pipeline services. So once you run this job, what you will get is a pipeline runs inside the Vertex AI pipeline UI. And if you click on the pipeline runs, this is how a Vertex AI pipeline auto side-by-side, a Vertex AI auto side-by-side pipeline might look like. So as you see, it's a very articulated pipeline. It has several components, and there are some of them are the model responses for both model A and model B. And one of the main components is represented by auto side-by-side auto-rated model. Once the pipeline successfully run, as you can imagine, you will get a series of artifacts, in this case, judgment tables and aggregated metrics. And you can explore those metrics in the Vertex AI pipeline UI. Also, thanks to Vertex AI Python SDK, you can retrieve both judgments and aggregated metrics inside the notebook environment. So for example, here we get the judgment, an example of judgments. So we have the response A, the response B, and we also get the explanation provided by auto side-by-side services that say that the response B is better than response A for some reasons with a certain confidence score. And as you do for judgment, you can do the same with the aggregated metrics. And you get the preference of the auto side-by-side auto-rated with respect of response given by model B and model A. So with this short video, I just show you how you can use auto side-by-side to evaluate a response provided by model A and model B. In this case, they were summaries. But as I mentioned before, what about introducing the human preferences in this process? So as I said, auto side-by-side support human preferences, and the process doesn't change. So let's see how it looked like, again, in the Vertex AI UI. So again, we start from the notebook inside the Colab environment. And the first thing that we need to notice is that now in the evaluation dataset, we have an additional column, which is named actual, and it provides the human preference with respect of a particular document. And this is just a summary that is provided by a human, an expected summary that is provided by human. Then we need to add the human preference column inside the parameters of the model evaluation pipeline, and we can run again a pipeline job. As before, a new pipeline runs will be created inside Vertex AI pipeline UI. And if we click on the pipeline run, we can see how the pipeline look like. And with no surprise, the pipeline is the same. The only thing that it changed is that now we provide an additional parameter and additional information that will be used by this pipeline to calculate the additional measures that I mentioned before. So once the pipeline finished to run, you can check those judgments and those metrics inside the Vertex AI pipeline UI. So if we click on the aggregated metrics, here you are, you have more metrics. Some of them I already explained you before. So with this, we ended this demo part. And as you can imagine, the same metrics that I see that I reviewed in the UI, I can get using the Vertex AI Python SDK. Okay, so to conclude, what I've just demonstrated you is how to use Auto Side-by-Side on Vertex AI to evaluate large language models, to compare large language model with a specific task, and check if those evaluations are aligned with some human preferences. This is just one of the use case of Auto Side-by-Side. For example, another one is using Auto Side-by-Side to evaluate attuned first-party models by comparing it against a foundational, not fine-tuned first-party model. But at the end, what I really want to highlight is that Auto Side-by-Side offers a flexible tool for evaluating large language models, and it empowers you to make informed decisions and optimize your large language-based applications. With that, up to you, Irina, to handle in conclusions.
Thank you. Thank you for this demo. All right, take homes before we start QA. So, as I mentioned in the beginning, there's a number of challenges in Gen AI evaluation, and it remains an unresolved problem. So we hope we gave you some pointers on how to start tackle this issue. Second, we need an automated method to scale evaluation of LLMs. I see a number of customers and teams eyeballing results, and though this is very, very important, it's also critical that we find some automated way to do evaluations at scale, to evaluate a number of outputs so that we have the right confidence to deploy, and so that we also find issues that aren't visible if you just evaluate 10 or 20 examples yourself. And ultimately, we've just seen Auto Side-by-Side, our autorator that supports you in A/B testing your LLMs. You can evaluate any generative AI model with that approach, and please don't forget all the elements we offer you to scrutinize this approach. So the raters we have in place right now for summary and QA, we've quality controlled and tested them against human raters so that we have alignment with what human judgment would be for summarization and QA. This is why we build out task-based autorators to ensure this alignment. But also ultimately, you yourself, as the user, are the ultimate judge of these outputs. So don't only look at the aggregate metric, look into the row-based results, look at the explanations and the uncertainty scores to see if what the judge does actually aligns with your preference. And with that, I'll end it and jump to questions. We received a couple of questions up front, so I'm just taking them first. So does Auto Side-by-Side support human-in-the-loop evaluations? Ivan, you've just shown this in the demo, so I'll hand this to you to summarize again.
Yeah, so as I demonstrated earlier, Auto Side-by-Side facilitate the human evaluations, and this evaluation can be served as the basis for generating additional metrics. And of course, as you can imagine, provide a more informed decision-making with respect of the model to prefer of the additional, or the not additional, but the task that you are evaluating.
All right. Next question. Okay. I would love to hear about the out-of-the-box functionality from Google to perform LLM evaluations. So Auto Side-by-Side for summary and chat, what we've just shown is one of these out-of-the-box functionalities. The other set of evaluation functionalities is our auto metrics functionality, which is an implementation of the popular metrics for generative tasks that can help you evaluate results. All right, I'll ping the next question to Ivan again. Just take a minute.
Yeah, so can we compare all the Gemini models and all the Palm models? I would say yes, because Auto SxS supports bring your own predictions pattern, as I show you in the demo. So with this feature, you only need to supply the dataset containing the prediction from one model to another. So maybe you have one model which is the, part of the Gemini family, and the other model which is a fine-tuned version of the Palm family. And by defining the appropriate parameters, for the model evaluation pipelines, you will get the metrics that I show you. So the answer, I would say, is yes, you can do that.
Okay, wonderful. And I'm not jumping to resources. I'm looking at the chat and looking at the questions that come in here. All right, is this useful for tabular data? So as mentioned, the auto side-by-side raters that we have today are working for summarization and question answer. We add more use cases, and we will also add a custom flow. So depending on the exact use case that you seek to tackle with tabular data, yes, this might be a useful approach, but I'm afraid we need to go deeper into the exact use case to give a good answer. The raters you have today, only summary and QA. All right. Next question, Emily. How do you run this against a Vertex AI model that is in production and not a test environment? Believe I don't fully. Ivan, can you take this? I don't fully capture the question.
Yeah, I would say that, I mean, we provide an API to interact with the services. Of course, you need to make the usage of the API aligned with your production environment. So, but in order to interact with these services, it's just what we show you in the demo.
Perfect, Emily. I hope this answered it. Please ask a follow-up if there's still open questions on that one. All right, let me jump to the next one. How to prepare a human evaluation summary at scale. So first of all, to have the kind of, you need around 500 input prompts for the auto side-by-side to work well. So think of also the size when you're preparing this. Think of patterns that you see quite frequently in the specific use case that you're tackling. Think of the clusters, I would say, so that you don't have just kind of one specific set of summaries, but so that you also touch the edge cases that are important for you. This is the advice I would give. If you have any type of logs or existing data that you can just reuse, so you don't prepare the data set, from scratch, but there's something you can take from your existing tables. That's obviously the most helpful piece. Ivan, anything to add? As you have a lot of experience with our customers preparing these data sets.
No, I think you cover most of the things I would mention. The only thing that I notice is that don't think about the model evaluation step at the end. So after you build your application, consider model evaluation at the beginning in such a way that you will start collecting the data that you need, and you will have everything set in order to, let's say, run a version of your LLM-based application, evaluate it, and if it's not perfect, you can use these metrics to improve the LLM-based application and go until you get the best that you can.
Perfect, thank you. All right, I think we covered all the questions. Yeah, here's a number of links to following community events. So yeah, check them out, have a look. We hope that this was helpful for you. You can find more information on all the evaluations in our documentation site on Vertex. And with that, thank you for taking the time. Thanks for being here. And we really hope that this was helpful and did its job to demystify LLM eval.
Thank you, everyone.
Thank you.